My name is Łukasz. Today I will try to find a key that will open the door to the world of the heat treatment and carburizing. Petra Prikner will help me to find this key. She is the CEO of Prikner company, a commercial heat treatment shop in the Czech Republic. I had the pleasure to meet Petra at the very beginning of my adventure with the heat treatment. I visited Prikner company for the first time 9 years ago as service engineer to start up the vacuum furnace. Today I come back to them after 9 years for the new experience. Petra, thanks for the invitation. Nice to meet you today.
You're welcome.
I know that you supply many different technology, and the question is, what is the most challenging for you?
Carburizing is the most demanding and challenging technology for us.
Why carburizing?
Prikner company is the commercial heat treatment shop, and customer requirements are very different. We always try to offer the best solution to meet customer requirements. We can choose among gas carburizing with salt bath quenching, low pressure carburizing with gas quenching, or low pressure carburizing with oil quenching. Each technology has its pros and cons, and making decision is very demanding sometimes.
I think it will be very interesting if you can show for us your health of the production shop and show for us these 3 different technology. Is it possible?
Yes, of course. My father started 40 years ago with furnaces that could only weakly control carburizing potential. Later, we could even predict carbon progress thanks to companies like Process Electronic. And then came the time of low pressure carburizing, which is completely different level. Gas carburizing plus salt bath quenching produces the best mechanical properties and the least distortions, especially when the temperature of the hardening salt is high, and high proportion of bainite occurs in the structure. From an ecological point of view, it is easier to handle salt than oil. Low pressure carburizing plus nitrogen quenching is excellent in its cleanness. The rate of carburizing layer formation is comparable to about 0.6 millimeters, and then low pressure carburizing clearly wins. We must be careful. In the achieved core strength, it could be weakness of this technology. Low pressure carburizing plus oil quenching means that oil quenching allows to heat treat low-grade steels by low pressure carburizing, and it makes this technology the most universal of all. However, you still have to deal with oil residues.
Petra, what are the most common requirements from the customer?
Today's trends are cost savings, and it leads to the choice of cheap materials. Therefore, there is a big pressure to carburize low-grade steels, like free-cutting steels, with excellent results and quality compliance. Really, we sometimes do miracles. But such a common carburizing is 0.5 millimeters wire on the part from 16 manganese chromium 5 material, plus perfectly clean surface and no distortion.
What was the most difficult requirements?
As I said, every customer is unique with his requirements, but there are specific small groups like cutlers, historical weapons, modelers, coiners, and one of them is the group of car racers, and they use chromium nickel steels for production of very demanding parts like shafts, gears, discs, and they require to increase service life by heat treatment up to 50% than usual. To construct such a process is really great skill.
Really interesting. What are the limitations for you?
There are technical limitations due to the furnace design, economic limits related to declining seriality, but you probably means technological limitations.
Yes, exactly.
One of the most popular requirements of customers is zero distortion. But distortion-free heat treatment doesn't exist. We can try to minimize distortions, but we will never eliminate them completely. Heat treatment is nature, and it only reacts what was introduced to the material before. Another typical requirement is hardenability. Thanks to our furnace with very high pressure, overpressure for quenching, we can bring excellent results even for low alloy steels, but it is still necessary to explain to our customers what is nonsense and what is real requirement.
If you don't want to have the destruction, that means no heat treatment.
Yes.
I am interested about what method do you use to minimize destruction?
You always keep in mind part, geometry, material quality, distortion requirement. For example, minimal distortion you can achieve using pneumatic hardening, and the higher flow temperature, the better. Of course, it is very important to pay attention the method of immerse in case of liquid quenching medium. Slightly different rules apply to the nitrogen hardening.
For which parts do you choose the gas carburizing, and when do you choose the low pressure carburizing?
Unless the customer determines the technology by himself, there are several aspects by which we decide. Part geometry, material quality, distortions requirement, for what the part is dedicated, surface quality requirements, costs, and last but not least, our furnace's occupancy. Each technology produces different mechanical properties like strength, toughness, and so on. And this is always most important to keep in mind during decision process. Customers' requirements are also very important. If the surface is to be visually beautiful, we always choose low pressure carburizing as priority.
Okay. Did you have any interesting case in your story that you can share with us?
For me, definitely carburizing of 5mm layer on a tapered roller bearing. Of course, it was very important to carry out the flawless carburizing process from the point of view of metallographical evaluation, and make a hardening process with as little distortion as possible. Thanks to low pressure carburizing and gas overpressure quenching, we provided an excellent result.
Okay, 5mm is really impressive thickness. What is the total time of the process?
Time of our process was 55 hours. While using gas carburizing, it needs almost 75 hours.
Okay, it's a big difference.
Yes.
What kind of trends do you see in the modern heat treatment technology?
Clearly, it is development of additive manufacturing technologies like metal injection molding or photostatic pressing and linked heat treatment. Additive manufacturing will revolutionize the future of automotive, aerospace components, medical instruments, dyes and tools, jewelry, etc. And heat treatment has to adapt to this.
By saying that heat treatment should adapt to this, do you mean some revolution in devices or some revolution in technology?
The change is already happening. Today you can buy HIP equipment including heat treatment. Neither the printer nor the MIM achieve nearly mechanical properties like metallurgical production. but they can produce a precise shape without the need for further machining. New powder materials are being developed, which can't be produced by metallurgical production, and there is no need for post-metallurgical processes. Our main task will be to improve the mechanical properties and deal with high porosity. HIP technology is already a higher degree, but equipment for HIP is very expensive, and companies in the field of heat treatment will have to ask themselves whether they will participate in this development. It is not yet known how much the HIP results will affect heat treatment. For example, it was already proven that very high pressure changes transformation kinetics in iron-carbon system.
What are the most typical heat treatments for the MIM?
Hardening or solution annealing with the following agent.
What is the unique for heat treatment after to MIM?
Choice of hardening technology with regard to required strength. We heat treat very complicated part shape. Their strength must be always verified. Of course, they have a large porosity, and we must deal with that and take into account always, because this part absorb the quenching medium, and it is not easy to clean properly these parts to be ready for following heat treatment or, for example, galvanic operations.
Do you see any increase in heat treatment related to MIM technology?
Yes, this trend has started 2 or 3 years ago, and now is rising very fast.
Petra, what is your opinion about HIP?
HIP is a highly promising technology, a key technology for future. And in my opinion, a heat treatment point will be to adjust mechanical properties and deal with the high corrosion. On the other hand, you can, as I said, you can buy the equipment, including equipment for HIP, including heat treatment. Really, it is the icing on the cake, but thanks to this heat treatment, just after HIP, you can strongly improve mechanical properties like yield strength, tensile strength, ductility, fatigue life, and even the surface quality.
Thanks for the nice discussion. I hope we discovered today the secret about carburizing technology.
Thank you, and great pleasure for me.
Thanks. Ciao. Thank you very much for the listening. If you have any question or comments, please tap on the chat.